What if everything you thought about reality was wrong? What if time, space, and even cause and effect don't work the way Einstein believed? Sounds crazy, right? Well, brand new evidence from quantum computers has just proven Einstein wrong, and it's rewriting the very fabric of reality. Imagine dedicating your life to proving the universe follows strict, predictable laws, only to be proven wrong decades later. That's exactly what's happening right now. But how did Einstein get it wrong? And what does this shocking discovery mean for the future of science and even your own existence? Stay with me till the end of this video, because what you're about to hear might change your entire perception of reality forever. Before we get into the shocking new discovery, let's take a step back to 1935 and address a simple question. Who was Albert Einstein, and what did he believe about quantum mechanics? Einstein, best known for his theory of relativity, revolutionized our understanding of space, time, and gravity. His equation, E equals mc squared, unlocked the secrets of nuclear energy and even helped create GPS technology. Without him, our modern world would look very different. But when it came to quantum mechanics, he had deep reservations. Imagine being Einstein, the genius who redefined physics, only to be told that, at the smallest scale, nature is random and unpredictable. Sounds frustrating, right? That's exactly how he felt. He couldn't accept a universe ruled by chance. That's why he famously said, "God does not play dice with the universe." Simply put, he rejected the idea that randomness was fundamental. He believed deeper, hidden rules were yet to be discovered. Now here's where things get really weird. Quantum entanglement suggests that two particles, no matter how far apart, can instantly affect each other. Einstein thought this was impossible and mockingly called it spooky action at a distance. It clashed directly with relativity, which states that nothing can travel faster than light. To challenge quantum mechanics, he and his colleagues Boris Podolsky and Nathan Rosen created the EPR paradox in 1935 in their paper titled, "Can Quantum Mechanical Description of Physical Reality Be Considered Complete?" arguing that the theory was incomplete. But here's the twist. Decades of experiments have proven Einstein wrong. Entanglement is real and works exactly as quantum mechanics predicts. If Einstein were alive today, he'd likely be fascinated, but still convinced there was more to the story. So, was Einstein completely wrong? Not entirely. He never denied quantum mechanics worked. He just didn't believe it was the final answer. And here's the mind-blowing part. This discovery even challenges aspects of his own relativity theory. Could he have been both right and wrong? Absolutely. His work shaped modern physics, but his dream of a fully predictable universe may never be realized. And that's the beauty of science. It's always evolving, just like our understanding of the mysteries around us. Now, let's dive into the big discovery. How did quantum computers prove Einstein wrong, and what exact experiment led to this breakthrough? Imagine Einstein sitting in front of a quantum computer today. He'd be absolutely stunned. For decades, scientists tested quantum entanglement with traditional experiments, but quantum computers changed the game completely. Unlike regular computers that process information in simple ones and zeros, quantum computers use qubits, which can exist in multiple states at once. This allows them to analyze mind-bending quantum interactions at speeds no classical computer could ever match. So, what exactly happened? Scientists used a quantum computer to simulate entangled particles on an unprecedented scale, running millions of tests to prove that entangled particles remain mysteriously connected instantly, no matter how far apart they are. This experiment was based on Bell's theorem, which shattered Einstein's belief that hidden variables might explain quantum mechanics. Using advanced quantum processes, researchers entangled two particles, separated them by vast distances, and measured their states. The results? Instant reactions, faster than light, without any hidden signals. If Einstein had been right, there should have been a delay, but there wasn't. This was undeniable proof that quantum entanglement is real. Unlike past experiments, quantum computers eliminated all loopholes, making this result more conclusive than ever before. In short, Einstein's classical view of reality just doesn't hold up. Quantum mechanics, with all its bizarre unpredictability, is the true nature of the universe. And if this is only the beginning, what other breakthroughs could be next? The technology behind this is mind-blowing. Superconducting qubits, ultra-sensitive photon detectors, and precision algorithms all working together to eliminate loopholes that plagued past experiments. Could a normal supercomputer have done this? Not a chance. Even the world's fastest classical supercomputer would take centuries to process this data. But how reliable is this discovery, you may ask? Scientists accounted for every possible error, making this one of the most airtight tests of quantum entanglement ever conducted. The verdict? Einstein was wrong. Quantum mechanics is real, and the universe is far stranger than even he could have imagined. So, what does this mean for the future? Buckle up, because physics is about to get even weirder. Speaking of physics becoming weirder, you might be wondering why. What does this mean for the future of physics? Well, get ready, because this discovery flips everything we thought we knew. Quantum mechanics has once again proven itself, but does that mean Einstein's relativity is outdated? Not exactly. Relativity still explains gravity and the large-scale universe brilliantly, but quantum mechanics rules the microscopic world. The real challenge now is figuring out how both can coexist, and that, my friends, could lead to something even bigger, a new theory that unifies them both. But here's where things get even more interesting. This discovery suggests space and time might not work the way we thought. If entangled particles can talk to each other instantly across vast distances, what does that say about the very nature of reality? Does this mean our physics textbooks are outdated? Well, not completely, but expect some major revisions. Scientists are now exploring whether quantum entanglement could help solve one of the biggest mysteries in physics: dark matter. Could invisible quantum connections be shaping our universe in ways we've never imagined? It's starting to look that way. And if you think that's wild, get this. Some physicists believe entanglement could be the key to understanding parallel universes, or even the multiverse. Could this discovery finally prove that we're not alone in reality itself? Well, perhaps. And let's not forget black holes. If space-time is linked through entanglement, black holes might hold secrets even stranger than we imagined. One thing is clear: physics is evolving, and we're standing on the edge of discoveries that could change everything. So are we ready for a universe far stranger than we ever thought possible? Because it's already here. To tell how relevant this breakthrough is, Google and other tech giants like IBM and Microsoft are playing a massive role in pushing the boundaries of quantum computing, which is directly tied to proving Einstein wrong. Google, for instance, made history in 2019 when its quantum computer, Sycamore, achieved quantum supremacy, meaning it solved a problem in just minutes that would take the world's most powerful supercomputer thousands of years to complete. That was a turning point. It showed that quantum mechanics isn't just some abstract theory. It's something we can harness to solve real-world problems. IBM and Microsoft are also investing heavily in quantum research, creating quantum processors and cloud-based quantum computing platforms that scientists worldwide can use to test quantum theories. Now here's where it gets even crazier. These companies aren't just making more powerful computers. They're building machines that defy the traditional laws of physics. Google's research has shown that quantum entanglement, what Einstein called spooky action at a distance, is real, measurable, and incredibly powerful. And if Einstein's idea, of a predictable universe was wrong, then what else about our understanding of reality might be flawed? The fact that private companies are racing to control this technology shows just how important and potentially dangerous it is. Now let's go even deeper. If quantum mechanics is correct, what does that mean for reality itself? Brace yourself, because reality might not be as real as we think. Classical physics taught us that the world is solid, predictable, and follows strict rules, right? Take instance, if you drop an apple, it falls to the ground every single time. No exceptions. That's how we've always understood reality. Things exist in definite states, and their behavior follows clear, measurable laws. But quantum mechanics? It says reality isn't fixed. It's a swirling ocean of probabilities. If entangled particles can affect each other instantly, then reality isn't just a collection of separate objects. It's a deeply interconnected web where things can exist in multiple states at once. And yes, particles can be in two places at the same time. Imagine dropping that apple, but instead of following one clear path, it exists in every possible path until you look at it. This is called superposition, and it has been proven in experiments. If that sounds crazy, it gets even weirder, because this also shakes the foundation of determinism, the idea that everything follows a fixed path. Einstein believed the universe played by strict rules, but quantum mechanics suggests the opposite. At a fundamental level, reality is probabilistic. No certainty, only chances. Does this mean Newton's laws are wrong? Not exactly. They still work in our everyday world, but zoom in far enough, and things change. Even our understanding of energy and matter is evolving. If everything exists as waves of possibilities, what even is reality? Could this explain parallel universes? The truth is, we don't know yet. But one thing is clear. The more we learn, the stranger reality becomes. And something tells me the biggest discoveries are still ahead. But wait, if quantum mechanics has already rewritten our understanding of reality, what happens when we apply it to technology? Could quantum computers now prove other scientific theories wrong? Absolutely. With their ability to process massive amounts of data instantly, they could challenge long-standing assumptions in physics, biology, and even cosmology. And when it comes to artificial intelligence, quantum computing could supercharge machine learning, solving problems in seconds that would take classical computers years. This could lead to breakthroughs beyond anything we've imagined. But it doesn't stop there. Quantum mechanics could revolutionize material science, creating superconductors that work at room temperature, ultra-efficient batteries, and materials yet to be discovered. In medicine, quantum simulations could accelerate drug discovery, leading to cures for diseases once thought impossible. And what about predicting the future? Since quantum computers analyze probabilities on a massive scale, they could make forecasting everything from weather to financial markets far more accurate. Even space travel could be transformed. Quantum technology may lead to faster propulsion systems and advanced navigation for interstellar missions. In cybersecurity, quantum cryptography could make hacking nearly impossible. But perhaps the most mind-bending question: could quantum computers prove or disprove free will? If reality is ruled by probabilities, do we truly make our own choices? And let's not forget teleportation. While sci-fi teleportation isn't here yet, quantum entanglement has already transmitted information across distances. Could this lead to human teleportation? And what about consciousness? If reality depends on observation, could quantum computers finally unlock the true nature of awareness? One thing is certain, this is just the beginning. Let's pause for a moment and ask ourselves, what if reality isn't as solid as we think? Quantum mechanics tells us that until something is observed, it exists only as a wave of possibilities. So, does that mean reality is just an illusion? In a way, yes. The act of observing actually determines what becomes real, suggesting that the universe is far more interactive than we ever imagined. Now, here's a mind-blowing thought. Could consciousness itself be quantum? If simply looking at something changes its state, does that mean our thoughts shape reality? Some scientists believe the brain might operate on a quantum level, which could explain intuition, creativity, and even how we perceive time. Speaking of time, what if it's not as fixed as we assume? Some interpretations suggest that past, present, and future might all exist at once. Could this mean time travel is possible? Theoretically, yes. We just haven't cracked the code yet. Some scientists believe quantum mechanics could finally bridge the gap between science and spirituality, showing that reality is shaped by both physics and perception. If that's the case, what else are we missing? In conclusion, quantum mechanics challenges everything we know about reality. If observation shapes existence, then reality isn't fixed. It's fluid, interactive, and possibly even conscious. Time may not be linear, and the universe might be far stranger than we ever imagined. As we continue to uncover its secrets, one question remains. Have we just scratched the surface of something even more mind-blowing? What do you think? Could quantum mechanics hold the key to understanding the very nature of existence? Let me know your thoughts in the comments below. Thank you for watching this video. If you enjoyed this, don't forget to like, subscribe, and turn on notifications for more. May God bless you all, and I'll see you in the next video.